Hi guys, in today's lesson, I'll be teaching us what limiting reagent and excess reagent under stoichiometry. If you have not watched my previous video on stoichiometry itself, I want you guys to watch my previous video. And if this is your first time coming across my video, I want you to subscribe to my YouTube channel at Divine Online Chemistry Tutorial. So let's commence with today's lesson. Now, please take note that because I'll be starting with what? With limiting reagents. Now, please take note that limiting reagents, they are reagents that get completely used up first in the chemical reaction. And please take note in a chemical reaction, the species at the left-hand side is known as what? The reactant. So, the species at the left-hand side is known as what? The reactant. While the species at the right-hand side is known as what? As the product. So the one at the right-hand side is known as what? The product. So please take note of what? Of this. That the one at the left-hand side is known as the reactant, while the one at the right-hand side is known as what? As the product. Now let's say, for example, we have what? A plus B reacted together to form what? C. To form what? C plus D. Now, don't forget that I'm explaining what? Limiting reagent. And earlier on, I said that limiting reagent, they are what? They are reagents that get completely used up first in a chemical reaction. Now, please take note that both limiting and excess reagent, they are both talking about the reactant aspect in what? In a chemical reaction. Though they enhance the product formation, but they are simply referring to what? The reactant aspect in what? In the chemical reaction. Now, please take note that when the limiting reagent gets completely used up in a chemical reaction, please take note that the formation of product stops immediately, because there will not be what? Any limiting reagents remaining, because it is what? Completely used up. So the reagent that gets completely used up first in the chemical reaction is known as what? As the limiting reagent. So that's all about what? Limiting reagent. Now, what about what? Excess reagent. Excess reagent, that the reagent that gets remained after the limiting reagent are be exhausted in a chemical reaction. So please take note that the reagent that gets remain that gets remain after the limiting reagent have been used up or have been exhausted in the chemical reaction is what we refer to as what? As the excess reagent. So you can call it excess reagent or what? Or excess reactant. So as the limiting reagent, you can also call it what? Limiting reactant. So you can also call it what? Limiting reactant. So you can also call what? Limiting reactant. Then for the excess, you can also call it what? Excess reactant. So, like I said earlier on, I said that when the limiting reagent has been completely used up in a chemical reaction, the formation of product stops, because there are no more limiting reagents in what? In the reactant part. Because it's the reactant that collide together for what? For the product to be formed. Now, having explained all this from here, let's talk about what? Steps for determining what? Both the limiting and what? And excess reagent. Please take note that there are steps for what? For determining the limiting and what? And excess reagent. So from here, we'll be talking about steps for what? For determining what? Limiting and excess reagent. Because we cannot just assume to say that this is what? The limiting reagent and that is what? Is the excess reagent. There are certain steps for determining what? Limiting and excess reagent in a what? In a chemical reaction. Now the first step is what? To balance a chemical equation. So the first step is what? Balancing of what? Of chemical equation. So this is the first step for what? For determining what? Limiting and what? And excess reagent. Balancing of what? Chemical equation. Now the second step after what? Balancing of chemical equation is to what? Find the what? Of number of mole. So the second step is what? To find what? Number of mole of each of the reactant particle. So the second step is to what? To find the number of mole of each of what? Of the reactant particle. We can only find the number of mole by what? By first of all balancing of the chemical equation. So you must first of all what? Balance what? Chemical equation before we go to what? To find what? The number of mole of each of what? Of the reactant. So you should please take note of what? Of this. So the last step is to what? Divide by the by So the third step is what? And the last step is what? Divide by the coefficient of what? Of the reactant. So the steps involved in what? Finding, limiting, and excess reagents include the first step is what? Balancing of chemical equation, which is essential and the basics. And the second step is to what? To find the number of mole of each of what? Of the reactant particle. While the last step is to what? To divide the to divide by the coefficient of the reactant. So this is the what? The third step, and these are the steps for what? Determining what? Limiting and what? And excess reagent. Now, having brought out this out, now let's now tackle what? Questions, jam question related to what? Related to this part of what? Of stoichiometry. So, under limiting and excess reagent, this is a typical jam question. Now, the question says, in the reaction which is N2 plus 3 mole of H2 equal to 2 mole of NH3, which happen to be what? Ammonia. It says 1 mole of N2, which this N2, react with what? 2 mole of H2, which is hydrogen. Now, the question says, the limiting reagent is A, N2, B, H2, C, NH3, D, ammonia. Now, if you look at this question very well, you are going to use those steps I gave earlier on to calculate this question. That's to find what? A limiting reagent. Now, but the first step is to what? Balance the what? Chemical equation. Now, and if you look at this question very well, they already give us the chemical equation and they already what? Balanced it for us already. Now, I will just break it down here again, which happens to be what? N2 plus 3 mole of hydrogen gas to give us what? 2 mole of ammonia, NH3. But in some cases, they will not balance the equation for us. They only just give us the values, then you bring it down to what? Balance the equation. But in this, they already what? Balance the equation for us. So first steps was balance chemical equation, which are already done for us in the question already. Now, the next step is to what? Find the number of mole of each of the reactants. The particles are the left-hand side of the reactant, while the one at the right-hand side is what? The product. Now, the next step is to what? Find the number of mole. Please take note that the equation for finding number of mole is what? Mole. Please think of this equation. Mole equal to what? Mass divided by what? Molar mass. So mole equal to what? Mass divided by what? By molar mass. So you get the number of mole of each of what? Of the particle of the reactant. But in this case, they already given us the number of mole already for what? For the N2 nitrogen gas and what? For the hydrogen gas. Because they say 1 mole of nitrogen gas reacts with what? 2 mole of what? Of hydrogen gas. As you can see, they already given us what? The moles already. In some situation, they only give us mass. Now, if they give us mass, we use this formula, number of mole, which is what? Mass over molar mass, to find what? The mole. So the mass they give us the equation divided by the molar mass of what? Of what? Of the element. We'll get what? The number of mole of each of what? The element that we are being given. But in this case, they're already giving us the mole already. So no need to find what? Mole. It's just what? Go straight to what? To the calculation. So since we are not finding the number of mole, now what we are going to do is to what? Divide each of the number of mole they give us in the question by the coefficient. Now, if you look at it very well, you see this nitrogen gas that's here. Even if there's no value here, it tells us that we have just 1 mole of what? Of nitrogen gas. Now, what I'm going to do here now is that we are going to divide the number of mole by the coefficient of what? Each of the reactants. So the number of mole, we are going to start with the first one, which happens to be nitrogen gas. So it will be what? Nitrogen gas, which N2 equal to, now the number of mole of this nitrogen gas that they gave us is what? Is 1. In the question, 1 mole of what? 1 mole of nitrogen gas. So 1 divided by what? By the coefficient of what? Nitrogen gas. Like I said earlier on, the coefficient of nitrogen gas is just 1. Since there's no value here, I will just see only N2 here. It means that the coefficient is 1. So divided by what? By 1. And of course, 1 divided by 1 is still what? Is still 1. Then we'll do same for what? For the hydrogen gas. So it will not be what? Hydrogen gas, which happens to be what? H2 equal to, now the mole that they gave us for the hydrogen gas is what? Is 2. 2 mole of what? Hydrogen gas. So the what? 2 divided by what? 3. Are you seeing now? The coefficient here is what? Is what? 3. So 2 divided by what? By 3. So equal to, now 2 divided by 3, you now get what? 0 0.667 is recurring. So I just approximated 0.67. So you are going to what? Divide the mole by coefficient of what? Each of the reactants only. Are you seeing now? So for the nitrogen, I got 1. While for the hydrogen, I got what? 0.67. Now, because the question says what? The limiting reagent is what? That's what we're looking for. Now, the limiting reagent is the one that's always lowest. Now, if you look at it, 1 and the one 0.67. Now, 0.67 and 1, which one is the smallest? It's 0.67. Now, since 0.67 is the smallest, it therefore means that our limiting reagent is what? Is 0.67. Because in this reaction, nitrogen gas plus hydrogen gas to give 2 mole of what? Of ammonia. It therefore means that the limiting reagent in this reaction is what? Is the hydrogen gas. Are you seeing now? So the limiting reagent in this reaction is what? Hydrogen gas. Because in this reaction, it is the hydrogen gas that will get exhausted first. So it therefore means that our hydrogen gas, which have to be what? H2, is the limiting reagent. So because after calculating, the one that is the least, that is smallest, happens to be what? The limiting reagent. And of course, 0.67 is for what? Is for hydrogen gas. And this one is for what? For nitrogen gas. Now 0.67 and 1, which are the least? Is 0.67, which means that 0.67 is our limiting reagent. It therefore means that this one is our excess reagent, which happens to be what? Nitrogen. So if hydrogen gas is our limiting reagent, it therefore means that nitrogen gas is our what? Our excess reagent. Now our answer to this question is what? Hydrogen gas, which happens to be what? Option B. Hydrogen gas. So with this, we have come to the end of today's lesson. Please, if you find this class very interesting, I want you to subscribe to my YouTube channel at Divine Online Chemistry Tutorial. Bye, and see you in my next post.